Priority. Scheduling is more than just deciding which process runs next. It's about organizing tasks based on importance. Imagine a queue where some jobs simply matter more, and the system must reflect that. In this course, the rules are clear. A lower number means higher priority. Priority 1 always outranks. Priority 2, and so on. If a process has priority 1, it will run before 1 with priority 3. So, how do we assign these priorities? There are internal factors, like the process's time limits, memory needs, file usage, and the ratio of CPU to input-output work. There are also external influences, including the process's business importance, the type of user, whether they're part of the system or a regular user, payment, resource allocation, and administrative guidelines. Let's walk through a practical example. Picture 5 processes arriving over time. Process P1 starts at time 0, with a burst time of 10 and priority 3. P2 arrives soon after with a short burst, just 1, and the highest priority of 1. P3 and P4 follow, each with different burst times and priorities. P5 joins with priority 2. Non-preemptive priority scheduling means that once a process starts, it runs until it finishes, regardless of new arrivals. In this scenario, P2, though it arrives after P1, jumps ahead because its priority is higher. The sequence becomes P1, P2, P5, P3, P4. The timeline shows P1 runs first, but as soon as P2 arrives, its importance elevates it in the order. Switching to preemptive priority scheduling, the system is even sharper. If a new process arrives with a higher priority, it interrupts the current process. So, when P2 appears, it preempts P1. Later, P5 slips in, preempts again, and the order keeps shifting based on priority. But there's a challenge: starvation. This happens when low-priority processes never get their turn, trapped in indefinite waiting. The solution? Aging. Over time, a process's priority increases, so even low-priority jobs eventually move up. For example, after every 15 minutes of waiting, a process's priority might gain a bump, pushing it closer to execution. Finally, a special case: shortest job first, or SJF. Here, priority isn't set directly. Instead, it's calculated as priority equals 1 divided by burst time. The shorter the job, the higher its priority, a natural fit for systems seeking quick completion. Priority scheduling forms the backbone of many operating systems. It brings order, efficiency, and fairness, especially when you understand its conventions, challenges, and solutions.